The name of the project is Restone, and the area of research is looking at how to recycle or repurpose building and construction demolition waste. The reconstitution process that we carry out basically starts with inert demolition waste. So it will be of this form, large pieces of limestone. And having said that, I need to add that this process is not just applicable to limestone, it's also applicable to concrete. So it's either limestone on its own, concrete on its own, or it could be a mix of both. From the large aggregate, we come and we make smaller sized aggregates. And from that, we crush it even further to make it smaller until we get it to the point where it's literally a powder. Once we have that powder, what we do is we mix it with a cementitious binder, water, a few special chemicals, and we then take that mix and we place it in a mold.
Different units require different apparatus, different forms, different molds, which we all have to design ourselves because there is nothing on the market for it. And we produce things like bricks, flex stones, and one important aspect of this is not can we make it, but will it last? The problem of durability. And we have recently constructed a small room at the alley. It's been there now about 6-8 months for that purpose, so that we see how the thing will weather. The project is trying to solve the acute problem that the island is facing in terms of the quality of the local stone. There is no stone. A good stone is very rarely available, and we are turning more to bricks, which is not really part of this island. And the second thing is that with a lot of construction waste, we are throwing away construction material and bringing in new material. And that is obviously, it is, as the term itself says, it's a waste. So what we're trying to do is to use that waste and reproduce what was before. The environmental benefits come from that you are using waste. So we have something which is sustainable. We have had our samples made, crushed, turned back into powder, redone again, even for 3 or 4 times. And every time we could make practically the same material.
The project was funded from the Mcst Fusion Research Fund. And yes, it was instrumental in bringing this to the point that it's at this point in time. What the Fusion project obviously did for us was that we could carry out more testing, because now we had the funding to get the materials we needed to do testing and the equipment. And it also linked us with industry. So having a commercial partner, it wasn't just a theoretical study. Now we were looking at how to cross the bridge from the lab to industry.
University is not designed to run a business, but it's designed to do research. So we can take such technologies and inventions to a certain stage, and it's inevitable that we bring in companies and industrial partners to help us take the technology further. And the Mcst Fusion program is a great opportunity for us to team up and collaborate with these companies and work hand in hand to advance the technology and ultimately take it to the market.
In this project, we partnered with Hallman Vella. They're our commercial partners in the Fusion project. They're very important to the project. So again, we have managed to make not just small blocks like this, but we've made blocks which are 1 meter by 1 meter by 3 meters long. And Hallman were principally interested in making a cladding product. So they make a big block and then they cut it like granite. So that they cut it into thinner sheets and then use it as a cladding.
The difficulty in this process is to align interests and motivation of the two parties, because we are a research organization, but the company is a for-profit organization. And we have to find the synergies, how we can work together. And for example, in this project, the technology is patent protected. So we have protection in 8 countries in Europe. for the technology. And one possible way to take this technology out of the university is to license the technology to industrial companies.